Hello, everyone. Welcome to our webinar today. My name is Sonia Winkleman. I am the Director of Net Zero Energy Housing at the Canadian Home Builders Association. And before we get started, I have a few housekeeping items I wanted to run over with everyone. First of all, I wanted to let you know that you're going to be in listen-only mode for the duration of the webinar. And that you will be able to ask questions. If you could please use the question section of the dashboard. I know there's both chat and questions. But if you could please use the question section, and then we will relay those questions to the presenters at the end of their presentations. Also, we wanted to let you know that this webinar is being recorded, and CHBA members will be able to access this recording as well as the slide deck on our website at chba.ca/nzwebinars. And I do have that URL will be posted at the end of the slide as well, at the end of the presentation, so that you have that for your information. So in regard to our webinar today, so I'm sure you guys all already know what we're here to talk about, but the title is 10 Steps to PV, a design build guide for builders. This is a newly released NRCan Planning and Decision guide for solar PV systems, and it offers an integrated design strategy to support builders to seamlessly integrate solar PV into their projects. Key solar design and installation challenges are explained and demystified in this fantastic guide. The design teams are guided through intentional steps, clearly defining solar energy production goals, solar array placement and attachment methods, electrical and structural impacts, and technology choices in the design stage, avoiding common pitfalls and improving solar PV build integration. This 10-step guide provides a roadmap for builders on their path to installing renewable energy systems on their homes. So we're going to have a really great dynamic and interactive demonstration by our fantastic presenters. We have Ben Giudici here from the Riverside Energy Systems, as well as Jonathan Zerke. He's builder and president at Sunbuilt Custom Homes. And then, of course, we also have our friends from NRCan Leap. We have Alistair Lerwell, who's going to also be on the call to talk to you a little bit about what NRCan is working on as well. But before we begin, I also have a few other slides I need to roll through here. One of them is to recognize our sponsor member, Owens Corning. They are our lead sponsor and are sponsoring our 2021 webinars for this year. And then we also, of course, want to say thank you to our bronze sponsor members, All Weather Windows, BASF, Enbridge, Fortis BC, and Panasonic. And Brett's going to get us kick-started to talk a little bit about the PV activities we're doing here at CHBA for our net zero program.
Great, thanks, Sonia. So I did just want to talk, I know we're going to be chatting quite a bit about detailed PV design today and the relationship between the builders and the PV installers. I wanted to bring in the energy advisors into the discussion and kind of give a little bit of the baseline information about how energy advisors fit into the net zero program, specifically with photovoltaics and PV design. So just as a baseline, before I get started with my couple minutes here, I want to just confirm our understanding of what net zero means for the CHBA program. So many of you have probably heard this before, but net zero just means that we have renewable energy installed to offset the annual estimated energy consumption of the home. Whereas net zero ready is the exact same house, but the renewable energy system just isn't installed yet. So a couple things to go over in terms of the role of the energy advisor. The main piece we talk about to our energy advisors in our training and then the mentorship process with them is defining the energy budget. So qualified net zero energy advisors are certainly experienced energy advisors with a variety of Energy Star homes and EnerGuide labels under their belt, but sometimes they come to us and they don't have as much PV experience as they need for net zero. So that's a big part of our training. And the reason PV is such an important part is because based on our definition of net zero, we're defining our energy consumption versus our energy generation. So it's a really important cyclical process that we need our energy advisors to have at least basic levels of PV design so that they can make some decisions on that process and help the builders out in terms of cost effectiveness. You can see on the bottom left of the screen there, I have a cyclical design where I show kind of some different processes to get to a reasonable level of PV to find a net zero home. So at the start there, we have just a design of a home with a few panels. It's at 20 gigajoules. Then we make some small changes to get the home all the way up to 45 or 50 gigajoules, and that's what you see on the left there. So that's kind of the cyclical process that we really make sure our energy advisors are comfortable and willing to work through in their design. Of course, our big recommendation to them is always to also consult a PV professional. Another piece I'll mention when we look at net zero ready homes is just what are the physical requirements of a net zero ready home. We know that they're in fact modeled to be net zero ready if PV was installed, but what they do have from a technical standpoint are a couple things that are checked off in our verification forms. We want to make sure the PV supply breaker can actually handle solar in the future. There's conduit going from the roof to the attic, electrical panels ready for an extra breaker. So we do want to make sure these homes are solar ready, even if they're only net zero ready and don't have the renewables installed. I'll jump to the next slide, Sonia. All right, so now we're looking at a little more detail about the training and tools. So for our net zero energy advisor training, we really take a three-prong approach. The first being PV knowledge, the second, the tools we provide them, and the third being verification. So on the PV knowledge side, as I mentioned, the big thing is we highly recommend that they get in touch with a qualified PV designer to help them out in making these decisions. We do teach them about things like the impacts of shading, calculating wattage, some best practices in terms of conversion factors, some rules of thumb to give them a better idea upfront if this project is even at a stage where it can be net zero ready or net zero, or if the builder needs to change their plans right off the bat before getting into kind of the efficiency side of things. In terms of the PV knowledge, we do also give a lot of this baseline information to the builders that are qualifying as net zero builders to make sure that integrated design process that goes on between all parties, the PV installers, HVAC designers, architects, that they're all involved and all have at least a good understanding of the photovoltaic side, because it really is the energy budget and the big piece for these net zero projects. A little bit more about the net zero side of things for that IDP process is we talk a little bit about the fuel breakdown. So if the home is going to still have natural gas or if it's going to be all electric. Because our program is fuel agnostic, if it has natural gas, that means a small portion of the PV or the modeled PV may be offsetting natural gas, and in a general net metering situation, the PV might not be giving credits for that. So we talk about that. We talk about what we've seen in the program so far. What we've seen is most net zero homes tend to go all electric and get those credits for PV generation. And then a lot of the net zero ready homes that are just modeling PV still have natural gas hooked up. In terms of the tools, we go deep into HOT 2000, which is the modeling software the energy advisors use. It's a very accurate software in terms of developing the PV generation estimates. It'll have similar estimates to what other PV technologies provide, but what it doesn't provide is the advice and the expertise that PV installers have, specifically when it comes to things like line designs and then also shading. The HOT 2000 piece won't be able to look at shading and the effects of trees or other buildings over the life of the project. So that's why we really recommend our EAs talk with PV designers and can provide the home, even if it's a net zero ready home, with a professional PV design. And then the last piece is just our verification forms. Of course, for the integrity of our program, we want to make sure we have some commissioning forms involved if it's a net zero home, and then if it's a net zero ready home, some checks and balances to ensure the home can actually get all the way to net zero. So that's kind of a little bit about where our energy advisors sit. They tend to be experts on net zero and really lead those integrated design sessions. So we want to make sure that they're up to date and ready to go in terms of photovoltaics.
Great, thank you so much for that, Brett. And I apologize I didn't introduce you. Brett is our coordinator for our net zero home labeling program here at the CHBA, in case anyone's wondering. So thank you so much for that, Brett. And now we're going to make Ben the presenter. And Ben and Jonathan and Alistair are going to talk obviously more about the guidebook and what this really, I guess, as an opportunity presents for both the builders and the energy advisors to learn even more about that fundamental knowledge that they need to have in order to get to net zero. So I'm really looking forward to this presentation. Take it away, Ben.
Thank you, Sonia. I'm excited to be here today with my friend Jonathan Zerke from Sunbelt Custom Homes, explaining the fundamentals of how to use this new decision guide. I'm going to give Jonathan a chance to introduce himself.
Yeah, good morning, everyone. Just wanted to encourage everyone on the call today, if you haven't had a chance to download the Planning and Decision Guide, take the opportunity to do so, and we'll be referencing throughout this presentation. So just wanted to give a quick bio on myself. I've been building high-performance homes now for more than 20 years, and obviously been sort of working with lots of different individuals. We're always trying to obviously build a better home and make a better product. We've been working with Ben now for about 6 or 7 years, integrating solar into our builds, and it's been a great adventure, and we've had lots of fun along the way. And so we'll be talking today about a project that Ben and I have been working on, and how that pertains to the guide.
Thanks, Jonathan. A little bit about myself. I'm Ben Giudici. I'm with Riverside Energy Systems in Kamloops, BC. We've been in business since about 1995 doing renewable energy. We have been involved probably since around 2010 quite extensively in net zero and other high performance builds. We were involved in designing and implementing one of the first net zero homes in BC under the Equilibrium program. And we continue today working with residential and commercial builders and others to provide PV consulting, design, build, and installation services. The guide that we recently authored for NRCan was intended to do a few things for builders by elevating PV from its typical placement as an afterthought or a last resort, elevating it forward into the integrated design process with the goals of reducing pain for builders and installers alike, and giving better results in PV installs and achieving desired outcomes rather than falling short. A great example is this picture on the left of a solar-ready home that we were involved with, where we were not invited into the design stage, but we gave some pretty significant warnings and advice up front, and nevertheless showed up and discovered the south roof peppered with vents, which looks in the end very unattractive, and resulted in a smaller array than the owner had wanted being able to be installed. We want to get better results like the installation on the right-hand side. So Jonathan, did you have any comments on that?
Yeah, I just wanted to comment here. Some of the pushback on solar, not only from homeowners, but from builders, has been curb appeal. And what does it look like from obviously the street? If you start right from the beginning and integrate solar into a project, and that's part of your solar awareness goals, solar can be blended into a project where you may not even be able to really see that solar is part of that project. So
I'd like to jump in here and give you guys a little bit of context about where this guide came from. So the LEAP team developed this guide because builders wanted clarity when starting to incorporate solar PV systems into their new builds. This started with a LEAP forum in Vancouver and soon grew into a series of presentations. Sonia and the Net Zero Council has hosted some of these solar presentations. The result of these presentations was builders requesting a document which they could use with solar consultants. So the LEAP team, with the help from Ben from Riverside, created this guide to fill that need. Following this presentation, Sonia has agreed to share a list NRCan and CanRe have compiled of solar consultants from across the country. We hope this will help builders make new contacts and start a discussion about how they want to begin to integrate solar or solar-ready components into their new homes. The LEAP team would also want to hear from builders who are interested in trialing the guide, and we'll be following up with an email after this meeting. Thanks.
Yeah, thanks, Alistair. And just to your points there, a second large underlying motive for the guide was, as Alistair just mentioned, was to reduce risks and confusion for builders so that solar could be integrated with more confidence and more seamlessly into the design and into the build. So common confusion. Will solar work for my project? What are the electrical impacts? How many panels will I need? Does this make any sense? What about the structural problems that might ensue? My roofer may not warranty the roof anymore. And then lastly, we want to avoid this question in red where the owner just throws up his hands and says, well, look, let me just build the house and can't you guys just add it later? This does not commonly lead to the best outcomes.
Yeah, not thinking about solar in the design stage, it's kind of like building a house without a set of plans. We as builders, you might get it done, but the pain and agony you're going to suffer is you're not going to want to do it again. So that's the big part of what the guide is all about, is really understanding the process and doing it and doing it right from the beginning. So part of what the guide is based on here is we're going to go through an actual example that Ben has gone through with us. We started out with this development that we did a few years ago. It's a 16 lot development. And a big part of what I wanted to do is I wanted to integrate solar into our builds and make it part of each one of the homes in this particular development. So we started down the process. We were already building a high performance home. So we basically got our energy advisor involved, as we always do at the beginning of the project. And we said to him, this is what we want to do. We obviously got Ben involved and said, hey, Ben, what might this look like as we start to go down the road to integrate solar into this project? So the proposed home that we started with is a 2,800 square foot single story home. And our goal with this home was really to highlight to our customers what solar would look like or what it could do for us on this particular home. So once again, we asked Ben to take a look at this. So with the information that was provided from our energy advisor, we started to work through the guide.
So the guide consists of 10 key decision steps that are to be made during the design process. So it's possible to make changes and shift priorities along the way and be more confident in the outcomes. It results in improved coordination during the build, and it will result in the builder being able to more confidently not just use PV, but even enthusiastically champion it. So let's work through this example together, Jonathan.
Yeah, and for those of you that are following along in the guide, you can see it's, yeah.
So the guide does consist of these 10 steps, which are quite clearly fleshed out, but perhaps the most important part of the guide in terms of deliverables is Appendix B, which is an integration worksheet, which serves as a roadmap of the decisions that were made as each step was taken in the guide. And then it also provides a permanent record that will inform the design and the installation methods that will follow. So we're going to begin with clearly step one. We'll start at the very beginning. And the step one of the guide is really to get very clear on what the builder's goal is for solar with that project. So Jonathan, maybe you can tell us what your goal was.
Yeah, so as I mentioned earlier, we had this high performance development that we were really trying to market. So we wanted to make this subdivision differentiator. We wanted to really show that we could do an entire development and have solar involved. So we started out with a build cost of about $650,000 for this particular home. And we were already incorporating a high performance building envelope. So that would represent about an $8,000 upgrade for the average builder. So that was already included in our particular project. So we took a look at this, and our goal was really to achieve that net zero. So we wanted to look at, is that possible, and what are the costs? What would the costs be involved to do that? So again, went back to Ben to sort of figure out what that could look like.
So in the guide itself, there's 4 options suggested as preferred goals. In Jonathan's case, he was wanting to go all the way to a full net zero energy home that would perform to that level. Optionally, builders might choose a home that's net zero ready, or maybe PV ready, or alternately, even PV equipped, where you would partially equip the home with PV and not have the intention of completely offsetting the consumption of energy. But in Jonathan's case, it was option 1D. He definitely wanted the building to be net zero. So Jonathan, what we did here is we used some 3D modeling a building to look at how solar could be mounted on your roof surfaces. There was no south roof space available, which would have been our preference, because we can harvest about 1,020 kilowatt hours a year for every kilowatt of solar deployed there. Not an option in your case, but you do have a lot of west and east roof space. Using those roofs, because of their pitch being fairly steep, there's a fairly significant reduction in the amount of energy each kilowatt of solar would harvest. You'd be down to about 890, so about an 18% reduction. However, the good news is you've got enough room on the west roof to definitely get you all the way to the 9,000 kilowatt hours your EA predicted we needed to generate to be net zero. Or alternately, there's enough space to use a combination of east and west to get you there. So how do you feel about how you'd like to proceed?
Yeah, so after looking at what you've shown us here and reviewing the information, I'm not able to necessarily reach the production that I was hoping for with these particular panels. So I'd like to take another look at this and see what we can do to sort of design some south-facing placement for solar to make it more productive. So with the information that Ben had provided for me, we took a look at what we could do to provide a little bit more of a south-facing slope and make that solar more productive. So one of the options that I looked at, and again, we're in the design stage here, I looked at removing a dormer. And after evaluating the removal of the dormer, it was determined that we could probably get about 3 kilowatts of solar in that particular roof space. That would make the solar much more productive, and we'd also save costs on that particular dormer. So by saving that additional money, we came back to Ben and said, hey, what would this look like if I did provide you with that south-facing slope? And instead of maybe going to that net zero, maybe just providing a net zero ready with some solar already equipped on it.
Well, if you remove that dormer, that would give us space for in the order of 3.1 kilowatts of solar, and that's going to harvest around 3,350 kilowatt hours a year. So I expect that'll put you in around 35% of offsetting the electrical energy needs. So the home would be PV equipped, and it would be net zero ready. Your client would realize immediate benefits, even though the house is not fully net zero. There'd be immediate benefits on the energy savings, and we could design it in a way that it could be easily upsized to give you full net zero performance in the future. So how does that sound?
That sounds pretty good. That's the way I'd like to proceed.
Okay. So what we've wound up with is you've shifted your strategy a little bit. The home is net zero ready, and we're going to equip it with PV as well, but not take you all the way to net zero performance. So that's excellent, and that's the best of both worlds. And I love the idea of builders beginning to understand that solar is not an all or nothing proposition. There's a lot of benefit to your customers to partially equipping the home with PV right up front, even though you may not be getting all the way to net zero. So I love that strategy. Okay, the next step is to iron out what the utility connections option are for your generation and to identify any other constraints at the build site that could affect the way solar will perform for your project. So because we're in British Columbia, the only means allowable for grid connecting any generation is through net metering. So we'll be doing this project through BC Hydro's net metering program, Jonathan. So you don't really have any other choices on this step. In other parts of the country, there's situations where potentially some sort of feed-in tariff arrangement may be available. There may be other parts of the country where it's not possible to overgenerate and your connection has to be self-use only. In your case, it's net metering, so that takes care of step 2. The other thing we've done for you is we went to the site and we did a solar access assessment using a solar camera, and we've determined that you've got excellent annual solar access. It's essentially 100% with very, very minor shading in the early morning and late afternoon from some trees that are nearby. But that will not affect substantially your performance. There will be a little bit of self-shading from gables on the south roof, but we'll deal with that later with our inverter selection.
Yeah, what's really cool about this, Ben, is you or one of your staff shows up and they've got a small camera and they put it on a pole, and within a few minutes they've got some solar photography. And I'd recommend that for all of you builders that are really considering solar. First and foremost, I would get a solar analysis. You really know what you're dealing with, and you can really dial in if there are any shading issues. And that'll help us later on, Ben, when we go to choose some panels.
Yeah, absolutely. So the third step is to confirm that the way the solar PV systems will be integrated are in alignment with the envelope and HVAC selections for the building. We want to avoid 2 scenarios. The first scenario would be the temptation to use a whole bunch of solar PV to compensate for a poorly designed envelope and substandard HVAC systems. The other scenario I'd like to avoid is where we get overboard on expensive envelope improvements or HVAC improvements where we reach diminishing returns, and where it would have been wiser to begin to integrate solar sooner. With the current cost of solar, it's sort of changed the way solar PV experts give advice. In years gone by, like even as recently as 10 years ago, the conventional wisdom was to do everything possible to improve your envelope and HVAC, which is of course very expensive, before you added PV, because PV was even more expensive. But in the last 10 years, the cost of residential solar PV deployment has dropped by factors of up to 4 times. And so the decision to begin adding PV can start sooner in the process. So this step really looks at whether these 2 things are in alignment. And in your case, they are. This is the way it fleshes out. This table is in the guide, and the column number 2B here, is where you land because we're using net metering. Initially, you had thought you wanted the home to be net zero. You would have been down here. But then you backed off and decided, no, let's make the house PV equipped, and it will be intrinsically net zero ready because you have an enhanced envelope and enhanced HVAC already. So it's really a hybrid. It's a hybrid of these 2 blocks: PV equipped on a net zero home to get your building part of the way there with immediate benefits, and with a very clear plan for how to reach net zero in the future.
Yeah, and we'll talk about that a little bit later, Ben, why I actually did go with sort of this hybrid and what the benefits I felt that we would have. So we'll talk about that later, but yeah, it's really cool. We ended up with a bit of a hybrid here.
Cool. Thank you. So what we've done here, Jonathan, is we've worked through the first third of the guide, part 1, where we've nailed down the pre-design considerations. We have this hybrid of being PV equipped and net zero ready for our step 1 decision. The step 2 decision is net metering. In this case, there was no choice. And step 3, we've confirmed that your solar goals match the envelope and mechanicals requirements. And we decided already that there's not going to be a battery in this system, but we will be, of course, adding grid-connected inverter technology. So we've worked through some of the harder parts here already. So is this good so far?
This looks pretty good so far.
Okay, so on to the next step is where we nail, we decide very clearly what your energy production target is going to be in step 4. So we decided that about 3.1 kilowatts will fit. So my energy production target for you is going to be 3,350 kilowatt hours per year. This puts you at about 35 to 37% of what your energy advisor had said would be necessary to reach net zero, which was 9,000 kilowatt hours per year. This is less than your net zero goal, but the intention is that later you'll be able to upgrade the solar system and reach net zero. Exactly. So this is our step 4 target.
Yeah, no, that looks really good, Ben. I just want to mention here, one of the things that we've found as a high performance builder, and one of the reasons why I did not jump right on to going full net zero, is when this home goes through an energy analysis by the energy advisor in the HOT 2000 software, he uses a bunch of standard information to input based on the average use or the average individual use of that particular home. In our experience, we found that our homes perform better than what has been modeled. And we talk about this has modeled sort of scenario. So when we talk about high performance homes with our clients, we always let them know that this is the performance that we're targeted to reach as modeled. So we do find that in most of our cases, our homes do perform a little bit better. So by adding a little bit of solar on up front and maybe having the client run that home for maybe a year, now we can actually get actual energy requirements, and we can go back and take a look at what really do we need to make this home net zero. So it really has, Ben has mentioned earlier, it starts us down the road of that, really doing that, getting away from that all or nothing scenario, and really starting people out thinking about solar.
Yeah, and to that end, we know that there are some builders across Canada that have begun to integrate solar into all of the homes in their subdivisions on a smaller scale and leaving it up to the home buyers to upgrade as an option. And I think that's a wonderful thing for builders to offer, whether or not the home will ever reach the net zero goal.
Absolutely, and some of you may know one of our past national presidents has been doing that. Nathan Stone, in his current development, he's actually starting out right from the start, giving the client, I believe, 2 panels to start with, and then allowing the customer to add on after if they want.
Yeah, exactly. We've been helping him with that project, and it's been very, very well received. Okay, well, the next step, step 5, is really to sort out the array locations and the sizes, and we already know it's going to be 3.1 kilowatts of solar, and it'll be roof mounted in your case, option 5A. But I would like builders out there to be open-minded about where arrays might go. It's also common to mount solar on an adjacent structure like a parking shelter or an outdoor entertainment shelter, or even a detached garage roof rather than on the roof of the home. It's also possible to mount solar on walls or handrails or as window awnings, and it's also possible to ground mount if there's space. So all of these options have different pros and cons, and it should be really up to the builder and the homeowner to choose these things. But in your case, Jonathan, it's a city-sized lot, and I don't believe you have other options besides roof mounting.
No, in this particular case, Ben, just due to the design guidelines and the size of the lot, and the just roof mounted is our only option.
Right. Okay. Awesome. A very important thing to consider here is step 6, the electrical impacts at the point of connection for on-site generation. This is really clearly outlined in section 64 of the electrical code. And for electrical contractors that haven't done much renewable energy, this is often a pitfall, and it can lead to problems where service equipment doesn't have the capacity to accommodate the amount of solar required. So in your case, your solar system is modestly sized, and so your 200 amp panel that you've chosen does have the bus capacity to manage the initial 3.1 kilowatts and all the way up to your full system. So you're good to go there. But I'd like to warn our listeners that often this causes trouble. And what commonly will happen is the electrical contractor and the solar installer will be two different companies, two different entities. And even though they might do their best to coordinate, what can happen is a panel will be installed that can't manage the solar capacity required. And so, for instance, you know, the owner might have intended to install a 15 kilowatt system, and the panel maybe can only accommodate 9 because it was the wrong panel choice. So if we can get this clear during the design stage so that everybody knows what the service requirements are, it'll be easy to avoid this mistake. So in your case, you're good to go.
Excellent.
Another really important one is structural impacts. We don't want installers showing up and discovering that the builder, the roofer, the truss supplier are not happy with the fact that solar is going on the roof or being attached in a certain way. And so these structural impacts and attachment methods have to be agreed to at the design stage. So Jonathan, you're familiar with this, but I'll mention it to our listeners that there's typically 4 ways that solar might get attached on a rooftop. Option 7A would be where we use anchoring systems that are flashed and that secure into the roof substructure in some way. The second one, 7B, would be where we use anchors that are flashed, but that secure into the roof decking rather than the substructure. 7C would be where we have standing seam roof that is strong enough to allow us to attach an array using standing seam clamps, and that avoids roof penetrations, which is a great idea. And then lastly, if it's a flat roof or very close to flat, a ballasted system can be used where a calibrated array of concrete blocks are pre-engineered and used to hold the system down and to withstand wind and seismic loads. Again, that avoids penetrations, but it increases the dead load significantly. So all of these things need to be considered in advance so that we know that the structure has the capacity to handle dead loads, that the attachment methods don't violate truss warranties or roof warranties, and that there's no surprises for the builder or the construction crew. So Jonathan, I'm pretty sure you'd want to use option B, but maybe you could chime in and tell us your logic.
Yeah, so as you are aware, Ben, we have used both 7A and 7B, and 7B provides us with a little bit more flexibility. And for those people that, you know, are, what's nice is you can mount these directly to the roof sheeting, and then you can come in after and add some blocking if you wish, if you want to beef them up. What I want to emphasize here is the importance of right at the design stage, having your designer really indicate on your roof plan where the trusses are going to be. And as we talked about earlier on this particular project, that's the example, we've allowed for all of the entire surface that were shown, so both the east and west faces, as well as that south face, to be you know, solar ready trusses. Now in that particular project, it added about an additional $500 to the truss package to ensure that all of those trusses were solar ready. So I just want to emphasize here the importance of making sure that your solar goals are clearly indicated on your plans, your plans that you're releasing for construction and for permitting.
Yeah, so once the location of the array and the attachment methods are clarified, that should immediately go into the design drawings. And the issue for permit and the construction drawings, so that everybody knows how the array will be attached, where it's going to go, and where skylights and vents should not go so they don't interfere with the array. That's a really good point, Jonathan. Thank you. So we've now completed the solar integration design requirements, part 2. So in step 4 here, we've clearly identified the energy production target. So we're doing about 3,350 kilowatts to give you roughly 35 to 37% offset. We clarified that your solar access scores on site are excellent. We identified that the array will go on that south roof where you've cleared space by removing the dormer. And we've identified that even though there is very little to no external shading, you will have a little bit of self-shading from the gables, and we'll be addressing that with an inverter selection, which I'll highlight later. Step 6, we identified the electrical requirements for feed-in bus capacity, and identified that your panel your panel choice is good for not just the initial system, but the ultimate system size. That no batteries or bimodal inverter will be used here. We looked at the structural impacts, and everybody's clear on the structural requirements, and that you're using a solar ready truss strategy to meet that requirement, and that we'll be using flashed anchors that secure into the roof decking as opposed to being anchored into the substructure. So that really defines all the hard work. So at this point, everybody knows how this will unfold, and much of the rest of it is really just technology choice, which doesn't affect anything else we just discussed, other than the shading, the self-shading constraint, which we'll get to. So is this good so far?
Looks pretty good to me, Ben.
Okay. So the next thing is choice of solar module technology. Over on the left, we have the polysilicon choice 8A. These will be a little bit less expensive than monosilicon panels, although the cost difference is narrowed significantly in recent years. The alternate would be monosilicon, which is slightly more efficient, performs a little better at low light levels, and also better at high temperatures. These days, it's becoming increasingly difficult to even source polysilicon modules in the sizes we need for residential installs. So I'm going to be recommending you look at monosilicon options here. The 8B choice is monosilicon with a white backsheet, which makes the cells fairly visible. A lot of people don't like that look, and they prefer the all blacks, which use a black backsheet so that the cells are not visible. The aesthetic is considerably improved. Now, if you were going to be putting your solar on an outdoor picnic shelter or a parking shelter, I would be inclined to recommend bifacial modules. Also would work well for handrail applications. These would allow light to filter through. And it also gives the option of harnessing energy from the backside because there's active cells on the backside as well. In your case, because it's a flush roof mount, bifacials would serve no purpose at all. So I'm going to suggest a mono option here. I have a hunch you're going to choose the all blacks, but what do you think?
Yeah, I think on this particular project, and so just what I'd like to emphasize is what my solar awareness goal was on this particular project. And I mentioned this was a show home in a development where we wanted to be selling it. So I wanted folks, when they walked into the front of the show home, to be able to see that there was solar on the roof, but I didn't want it to really be obnoxious or right out in their face type of thing. So we chose a black roof and we chose the black on black panels so that the panels would still make a statement, but it would be a discrete statement. And that was really a big part of what our solar awareness goal was in this particular project.
Excellent. Okay, well, the next thing is inverter technology. And as you know, we could be using string inverters, optimized string inverters, microinverters, or a bimodal in the case of battery backup systems. I'm going to recommend, in your case, a microinverter strategy for 2 reasons. It's modular, so it'll allow us to expand the system easily later, by as few as 1 panel at a time. And it also provides a highly shade-tolerant design, which will help mitigate the self-shading from your gables. You may remember, but I'll remind you and our listeners that with a microinverter's arrangement, each panel or pair of panels has a small inverter mounted underneath it, right on the rooftop. And the microinverters convert the DC solar electricity directly to AC right on the roof. Comes off the roof as AC. And one of the big advantages of this method is that each individual panel can produce at full power, provided it's not shaded. And if any panels are shaded by cable shade or soiling of any kind, only those panels that are in the shade have a reduced output. So it's a very shade tolerant design. So this would be my advice. Are you in alignment with that?
Yeah, no, this looks good, especially due to the self-shading issues that we have. And just to clarify, there was some minor shading issues due to the sort of the gable ends that we had on either side of the south-facing roof. So,
yeah, so you could expect some morning shade from the east gable and some afternoon shade from the west gable. It'll be minor, but the microinverters will really help mitigate that.
Yeah.
Okay, and the lastly would be to get really clear here in step 10 on the monitoring methodology. Since you've chosen microinverters, the great thing there is that there is built-in monitoring that provides system level energy production records for daily, weekly, monthly, yearly energy production, as well as daily power output, basically minute by minute for the entire system. But what's particularly powerful is you'll have module level monitoring, so you'll be able to see how each individual solar panel is performing. This is great from a maintenance point of view, and it'll make it very clear if there's anything going wrong on the rooftop, say with soiling from leaves or dust or anything else that needs to be dealt with. So are you happy with this monitoring, or do you think anything more needs to be provided?
No, I think that's really important to be able to monitor the individual panels. And again, it just helps with our clients. They like to be able to go and look at each day and see what their solar production is. And that's a big part of what we try and do to market the solar. So I think this is a great option.
Okay, that's good. Well, we've worked through all the steps, so let's just document what you decided around steps 8, 9, and 10. You decided on the polysilicon all blacks. You decided that you're happy with the microinverter strategy, and we'll design the trunks on that so that it'll be easy to upgrade and add the expansion later to full net zero. Because you've chosen the flashed anchors attached to the decking, it'll actually be possible to do that upgrade without even getting into the attic. So that's important. You won't have to worry about your insulation being disturbed in the future. And then you're happy with the monitoring that comes intrinsically with the microinverter system. So that's great. So is there anything more, or are you good with the 10 decisions you've made?
No, I'm pretty happy with the 10 decisions, and it's been pretty clear on which way I need to go.
Okay, well, now that you've done this at the design stage, what I can do for you next is I can create installation specifications. So I'll write some specs for you that explain where the solar will be installed, how large the array will be, the type of modules you'll be using, how it'll be attached, the type of racking, and the microinverter system and how it'll be interconnected, along with a single line, so there's total clarity on how this is all going to be installed. And I'll suggest it, as you already suggested, that this all needs to show up in your design drawings, your permit drawings, and your construction drawings, so that there's absolutely no doubt how all of your installation steps will be impacted by solar, and so that your service providers will not have any confusion around how the solar may affect their contribution to the project.
Looks good.
Yeah, so this should give you a smooth handoff to the construction stage.
Yeah, absolutely. And I think obviously we want to really clearly show those drawings, but big thing is obviously talking with all of our service providers and making sure they're aware of what we're planning to do with the solar, and making sure that what they are planning for that particular project is properly integrated into our solar goals. And then a big thing I think is obviously the supervisor on the site understanding what the goals are and working with the trades as they, because there's a lot of things that aren't documented from trades that have to go through the roof, like vent pipes and plumbing stacks, and just ensuring that those trades are on board with where the solar is and where they need to put their service penetrations. And then lastly, because of the smooth process, Ben, that you've taken me through, we can easily integrate this into our schedule, and so there's going to be no scheduling issues with the solar installation. So all in all, I think going through the guide has been a really helpful process to get us to the state where we can actually make this all come together.
Well, that's great. It's been a pleasure supporting you with it. And so at this stage, I'd like to thank all of our listeners for bearing with us through the presentation, and open it up to questions and comments, and maybe even feedback on how we might further encourage use of this guide amongst builders and their design teams.
Yeah, that was a great presentation. Thank you very much, Ben and Jonathan. We do have some questions that have already come in, so I'm just going to scroll through them here and hit them off one by one. So we did have a question earlier on in your presentation, and Phil has said clients usually ask about an ROI. What is the best way to present the financial aspects of PV arrays?
Well, I'll maybe start in on that. As PV consultants and installers, we have a tool that we've developed that allows us to actually calculate ROI for each installation based on historical consumption, if it's a retrofit project, or based on projected consumption, if it's a new construction. It also specifically looks at local utility rates and allows us to do what ifs around what happens if the utility increases their rates, which I don't know about other parts of Canada, but it certainly happens in BC. And so we use that tool. And if you work with a PV consultant or installation company, they should be able to answer that question in a way that's relevant to your local rates and context. So just to answer the question for BC, like here in the Kamloops area with our permitting costs and so on, it's not uncommon to see ROIs for solar retrofits that are anywhere from 5% to 7.5%, and it's the business case is much stronger than it was even just a couple of years ago. And I would encourage builders to discuss this with providers in their area, because it's changing very quickly, and many builders are still thinking the payback times are much longer than they really are.
Actually, we're seeing some really interesting projects coming up, specifically one that's participating in our Net Zero MERB. It's basically a research project, and I think we've got one of the participants, one of the main consultants is on the line, so he might be able to chime in if I'm totally off base here. But what I'm hearing is that some of the builders are even looking at what we call a total cost of operation or ownership. So they're taking a look at net zero and the cost reductions you see in the energy reductions, and then when you've got a PV system in there, what does that mean to balance that out? And then how does that additional cost to upgrade to the net zero compare with like the mortgage and the energy cost, basically. So we've got one builder who's saying that you can get to net zero for 0 monthly cost because it does end up balancing out for his specific project. So of course, every project is going to be different, but absolutely the idea of communicating the financial part of getting to net zero, including the panels, is a really important conversation to have. And I think that more and more builders, as they start digging into their costs, are able to show that value proposition that just like when you buy a cell phone or a car, everybody's now looking at monthly costs. And so the decrease in the utility costs and the contribution, of course, that PV system makes is really, really important. So yeah, so Phil, I think that it is really a matter of kind of digging into where you're able to get on that balance on the ratio there. We do have some other questions that have come in. Simon is asking, in what situation would a battery system be recommended? What are the benefits other than in an off-grid situation?
Well, the benefits would cover off a few different scenarios. One of the most obvious ones might be to be able to back up essential loads, during a grid outage. So when I talk about essential loads, I'm meaning things like refrigeration, maybe some computer facilities to be able to stay connected with the world, emergency lighting, and the like. So one would be for backup against grid outages. Another one would be in jurisdictions that have time of day billing, which we don't have yet in BC, but I can't imagine that it's not going to happen in my lifetime. So with time of day billing, it's possible to save energy into your battery and then use your stored energy that was generated from the sun earlier in the day to ride through the high tariff period. That's a really good one. Another one would be in jurisdictions where there might be self-use limitations, where you're not allowed to export energy to the grid at all. You can connect to the grid, but not export to it. So in that case, you'd be storing your surplus energy in the battery and using it, let's say at nighttime when your solar isn't working. So those are probably three of the best ones.
Yeah.
And there's also potentially jurisdictions in Canada, certainly in the rest of the world, where there's also peak demand charges, aside from just energy charges. So you can use your battery system and inverters to shave peaks and save money as well. But that's less common in residential applications. It's more commercial.
Yeah, we have seen peak shaving and the other application you mentioned here in Ontario, where people are taking advantage of using the energy that they generated earlier on in the day for things even like EV charging, so that they're not charging their EV when they come home and they plug it in right when it's a peak hour. So yeah, those are some interesting applications for sure. I did want to just make note of the time. We've got 2 minutes left with a few other questions, so I'm going to try and go through them a little bit more speedily here. So one of them here, actually, Tex is saying, congrats on the format. The relaxed conversation using Q&A between the participants is very effective, along with the periodic summary. So thank you so much for that feedback, Tex. That's great. It's always nice to hear that the way we're formatting the webinars are working out well for the participants. Ryder also asked, is there any preferred guidelines forthcoming for tying a solar system into a vehicle-to-grid charger system? And will this allow less micro inverters to be used? I'm seeing this, the grid-to-car thing going on a little bit more. That's coming up in conversation quite a bit.
Yeah, that's a really awesome one. The technology is available to be doing that now, but it's not really approved in many jurisdictions that I'm aware of. I know that, for instance, in BC, that would be frowned on by the utilities. But I'm hopeful that it won't be long before this gets ironed out, because there's a lot of benefit, not just to consumers, but to the utility as well, to be able to use energy stored in electric vehicles to help with peak shaving during hours of the day when electric grid losses are higher. It's a win-win if we can make this happen.
And I understand too that the car manufacturers have to actually, the car has to be set up for that as well, which I don't believe all the cars are yet, the electric vehicles. So that's something that's going to have to happen as well. So I've got one more question here from Liz. She's asking, is there a cost implication to selecting microinverters rather than the more traditional approach?
Well, I'm not sure what Liz means by the more traditional approach. She might be referring to using simple string inverters. And yes, there is a cost implication. It could potentially be a little more expensive to use microinverters, but the advantages will outweigh those costs, particularly if shade tolerance is important. Then microinverters are one of the options. If there's multiple roof surfaces involved that are not all facing the sun from the same direction, simple string inverters are not as effective. And then lastly, of course, microinverters give you a more modular strategy where you can actually expand one panel at a time if you choose to. With string inverters, that's a little more constrained because typically the strings typically need to be at least 8 or 9 panels in length. But for sure, if it's a site where the arrays are all focused in the same direction, same azimuth and tilt, and there's no shading constraints whatsoever, simple string inverters are a great solution. It's just not a good solution for Jonathan's project.
Great. Well, that's all we've got for today. So I want to thank you so much, Jonathan and Ben, for a fantastic dialogue and a great way to present the content. And Alistair, thank you so much for bringing this all together, and Brett for your contribution to the call as well. I did want to just mention to everyone as well that we do have another webinar coming up on February 25th. BASF is going to talk about discovering the new generation of spray foam. So you can find more information at our URL, which is chba.ca/nzwebinars. That's also where you will be able to find the recording of this webinar as well as the slide deck. We'll be able to get that posted in the next couple days. So thanks so much, everyone, for a great call today, and wish you enjoy the rest of the day, and we'll talk to you guys soon.
Take care.
All right.
Thank you very much.
Bye for now.
Bye-bye.